Hello guys, I'm back. My name is Jeferson Costa, a chemical process engineer with expertise in design, and welcome to the Chemical Process Engineer Diary. In this series, I share with you what is the daily life of a chemical process engineer, working with plant design, I answer questions, and do some clarifications. And today, I will cover three main subjects, and they are, if I usually I see this kind of question, should I work with operations first before going to plant design? So I will do some comments related to this. Let's talk about how is the work in the field as a chemical process engineer. Usually time to time I need to go to visit some customers. I need to go to other cities or countries to do field activities, and I will talk a little bit about that. And also today I will talk about fluid package for water simulation. And this is very, very important because I have seen some publications, and it seems that people misunderstand a little bit about it. So starting with activities, field activities, as you know, currently I am doing some field activities and what I call field activities. Hello, Nilesh Kumar. Good afternoon. Hello, Henry. Hello, Henry. So talking about field activities, when we are working in plant design, the process engineer, usually if you are in a design company that works only with design, you will be located in an office. And this office may be in the town, and you will do your activities in the office most of the time. But when we are doing some new project, it's normal to go to the field in the location where the project will be installed to do some kind of verification tests, look for documentation depending on the company. And the further stage of the project, we have many stages in a project. We start with conceptual design, and after that we go to basic engineering, detailing engineering, and we go to construction and erection, commissioning, startup, and eventually troubleshooting. So when we are in the commissioning and startup phase, it's common, depending on the size of the company, depending on the structure of the company, that you go also to the field to help operations to verify the conditions to the plant, what is the set points for controlling, what is do training to operators. So I have some kind of experience. Because of that, I travel to some countries here in South America, for instance, and you are dislocated from the office that is your main basis to the field to do this kind of activities. And the what is very nice uh, related to this kind of activities or this role is you leave your home, your town, and you are able to visit and know other places. For instance, I am a Brazilian, I live in Rio de Janeiro, but because of that, I already visit many states here in Brazil that I would not do if I was considering vacation, for instance. And this is an opportunity, and this is a good opportunity for some reasons. The first thing is that you are able to be in touch with other cultures, even in your own country. Depending on the size, how is it? As you know, Brazil is, if I'm not wrong, the fifth biggest country in the world. You will have different kind of cultures, and if you go to other country, for instance, I already visited Argentina, Peru, Uruguay, and China. You will be able to find other cultures there also, and it improves your personal knowledge. It improves yourself because you get in touch with different people. But not only that, you will have the opportunity to find people that you usually are not familiar. You don't work regularly. For instance, When I went to Rio Grande do Sul to start a new plant there, a nitrogen plant there, I met technicians, managers, and the plant manager that it's not part of my regular work in the office. I didn't get in touch with them during plant design in regular basis. But if you are able to show your technical skills, if you are able to build strong connections when you are in these locations doing field activities, this can be very, very good to you because you never know the future. Eventually, these people will invite you to an opportunity in the opportunity, a local opportunity, or they will recommend you to another department and etc. So this is one of the benefits of going to the field to do leaving your design office to go to the field. Moreover, when you are in the field doing activities, you really understand the importance of plan design. I used this example sometimes I had a storage tank and I had more than 5,000 of CO2 installed of that, and the pipe engineer, instead of installing the isolation valve in the horizontal size, horizontal direction, you have the storage tank here, you will have a withdrawal pipeline, so it gets a vertical part and a horizontal part before going to the pump. And there was an isolation valve in this case. So you can install the isolation valve in the horizontal part or in the vertical part. And the pipe engineer or the pipe technician installed in the vertical part. And because of that, the weight of liquids was too many forces in the isolation valve, getting tough to open and getting tough to open, especially during the commissioning. And if this is kind of thing that you go to the field and you verify that, you will not let that happens again in your plan design, because you can do must be installed in the horizontal part of the pipeline. So this is kind of things that you only that when you go to the field you learn faster things. So um, okay, so this is one of the other benefits that you when you go to the field. Other thing is you have more interactions with your comrades or with your co-workers, especially when you are talking about commissioning. It's a small group that goes to the field, and you have the opportunity to tight relations, and that can be benefits to you also in the future for recommendations for new openings. And as I always told to you, it's very, very important to you build connections with people in order that they think about you when they need some help in the field of your expertise. And hello, Vishari. Nice to have you here, guys. I am doing streaming at my left side in the Instagram and at my right side in the YouTube. And let me see here. Uh, hello, Anis. Hello, Vishal. Topic today. I have three topics. The first one is how is doing field activities, how is the benefits and the benefits, or not so, and the benefits of working outside your design departments, going far away from your home. I will talk about also, should you work with operations before working with plan design? This is what is my point of view about that. And finally, let's talk about fluid package for water simulation. And thanks for your feedback related to pipe to pump selection. That was for sure a very video in YouTube, and very completed. It's not exhausted all the subjects related to piping sizing selection using Aspen high seas, but most of it was covered there. If you want to go, guys, you can go to my YouTube channel and you will verify that it's still available there. And getting these opportunities, let me talk about the fluid package in process simulation. What is the fluid package in process simulation? A fluid package is used in the IC, but there are, yeah, I think that in others process simulation, they use different nomenclature, but it doesn't matter. What matters is that when you are starting a process simulation, you need to choose a source of information that will calculate or get as reference all the properties that your fluids that you are working on. So by doing with process simulation for air separation plants, for instance, I need to inform the Aspen high Cs. Let's focus on Aspen high Cs, which is the source for calculating the nitrogen mass density, the nitrogen heat specific heat of the specific heat and the nitrogen boiling point and etc. So this is the same if I working with a group of hydrocarbons. I doing, for instance, a natural gas sweetening. So I need to inform what is the fluid package to the process simulation uses to calculate the absorption rate of the solvent and etc. And knowing the correct fluid package for your process simulation is very, very important, because based on that, you will have the characteristics of the components, and you will be able to size and select or size primarily the pumps, compressors, pipelines, and all the equipment that is available in the process simulator. And when we are talking about the simulation of hydrocarbons, is very, very often people use Peng-Hobson. It is an equation of states, and it predicts or it calculates what are the properties of the hydrocarbons. And per standards, people use Peng-Hobson most of the time. And there is no problem with that, but I have seen in some publications that when we are talking about water exclusively, when we are talking about producing steam or only a system with water, uh, what happens is that you should not use, or if you want to have the more accurate results, you should not use the Peng-Hobson of state. You shouldn't use the fluid package Peng-Hobson. And why you shouldn't do that? Because the equation of states do some considerations and calculations that if you compare the ASME steam, the fluid package that is available in the Aspen high Cs, you will get much, much more accurate results. It's when we are studying chemical process engineering, it's very, very common that to handle the steam tables with different pressures to get different properties of the water. You get the heat of vaporization, we get the boiling point, the dew point, and etc. And the ASME steam is fully based on these steam tables. So when I need to do a process simulation that covers only water, you should use the ASME steam as a fluid package. And why I talking to you about that? Depending on the interview that you are having the interviewer, eventually he will ask you some technical questions, and he may ask you what is the best fluid package. It's kind of questions that I should not do, but if you present me something and it get my attention, and you use Peng-Hobson instead of steam table, eventually he will not observe that, but who know that the steam table is the best for water simulation will get that into account. And if you are able to explain the reasons why steam table is best for using the process simulation instead of using Peng-Robson as standard for water simulation. Only water steam table uh, accepts only water for your process simulation. You probably will get some points. And if you publish your work or post in the social media, that is something that you should get worried about, because uh, uh, the main issue is not share wrong information. But if you can be more accurate as possible, of course, that people will not notice you more. And it comes to another thing related to the process simulation, and it is the volume flow in process simulation in Aspen High Seas. I covered this part. I talk about a little bit about it in my video, uh, sizing selection of pumps in Aspen High Seas. And what happens is that in the Aspen High Seas there are three kinds of volume flow to be considered. The first one is the not the first one, but one of them is the actual volume flow, and it is the actual volume flow that we uses when we are doing the sizing and selection of a pump. Because depending on the conditions of pressure and temperature, your liquid will have a volume, and it is that volume that the pump will circulate or will build pressure. So it's important to you understand that, because in standard conditions, when you do a double click in your material stream in the Aspen High Seas, you have information to add the molar flow, you have information to add the mass flow, and you have information to add the standard ideal volume flow. And the standard ideal volume flow is not the actual volume flow that you have in your process simulation. The standard ideal volume flow, it calculates the mass density of the fluid at 60 Fahrenheit and 1 atm. So 60 Fahrenheit is around 16 Celsius degree, and 1 atm is closer to 1 bar and closer to 14.7 psi. But if your process simulation is running a liquid at 80, for instance, I will talk about in Celsius degree, because in Brazil we use Celsius degree too much. If we are talking about fluid that's pumping, it's pumped at 80 Celsius degree, 80. It's far away from 15 Celsius degree. So the process of the fluid at 80 Celsius degree will be different, and because of that, the mass density will be different, and you will have not too much accurate results when you use the standard ideal liquid flow in your process simulation, uh, uh, instead of using the mass flow of your fluid. And that leads to another subject. The Currently in the process simulation, you will see in the heat material balance very often that we get information related to kilomoles per hour or moles per second, and etc. And the kilomoles per hour is a chemical engineering uh, unit of measure. We never refer to a process using kilomoles per hour. You don't say, my oxygen plant will produce 1,000 kilomoles of oxygen per hour, or my polypropylene plant will produce 10,000 kilomoles per hour. We never use this kind of measurement in the real life as chemical process engineers. Usually especially when we are go to the field, or when we are talking about operations, it doesn't interest to them. What we measure in the real life when we are doing production in plants is mass flow, especially when we are talking about sometimes when we are talking about liquids, or depending when we are not talking about gases, we use this mass flow. But when we are talking about steam, usually it's mass flow also. Or we talk about volume. And talking about volume, uh, the volume depends on the pressure and depends on the temperature. So you need also to know how to refer to the correct information of temperature and pressure that your volume is calculated. But it will be a subject to another live session. So the main point here, you will simulate a water stream. Don't use Penge-Robson, use steam, ASME steam as the fluid package in your process simulation. It's possible to add more than one than component list in your process simulation in Aspen High Seas, and it is possible to add more than a fluid package in your Aspen High Seas. So if you are simulating a hydrocarbon system, a cooling system, for instance, a natural gas cooling system with water, you can use Penge-Robson to streams that the composition is with hydrocarbon, and you can use the ASME steam in the same fluid process flow diagram. Process flow diagram, you can use the ASME steam to simulate the water part of your process simulation. Okay, guys, take that in considerations. I have seen some message here in your YouTube. So Science Now, can you please talk about different phases of plant construction from studies to delivery? So the plant construction is one part of the plant design. When we are talking about installing a new biomethane plant or a new oxygen plant or a new polypropylene plant, we have some stages from the paper or from the business starts. All the big plants start with the business and with the high management. There is a name for that. The high management, the directives, let's say like that. So uh, but we start a plan design with documentation, with paper, and as we says here in Brazil, the paper accepts everything. So you start with business start with negotiation, verify the market. If I installed here a new uh, liquid CO2 plant, it will be worth it to the company. I will have customers to buy that. I will have my price will be competitive considering that I will deliver it by trucks, or I have near industrial facilities that will consume that by pipelines, or how is the logistics for delivering my product. That is part of business. Usually the chemical process engineer don't work with this. If you work with plant design, it's not your duty to worry about this part of the project. But once business and the high management decides that a plant must be installed, uh, you participate in the earlier in the conceptual design of the plant. So it's time to, once was defined the amount of flow and the requirements for the product, it's time to verify what kind of process must be applied to that. I will give you some real examples. I am involved in a biomethane plant, and the biomethane plant uses biogas from landfill to produce biomethane. And business has the business did the meetings and talkings with the partner, and they decided that I will change some numbers. That we have 2,000 normal cubic meter per hour of biogas available to do biomethane. So now, to upgrade the biogas to biomethane, I have many technologies available. I have at least 4. I have adsorption, I have absorption, and in absorption, I have subcategories. I have cryogenics, and I have membrane. So this is the 4 main technologies that is available to do upgrading of the biogas. If we are talking about doing polypropylene, we have different technologies also, at least two, Spheripol, and there is another one. And for nitrogen, you can have different configurations to produce nitrogen, for instance. So, and etc. And as the chemical process engineer of the project, you must understand what are the main what the main capital and the main OPEX needed to run each one of this technology, because of course that your company will prefer to choose the smallest capex available and also the smallest OPEX available. If you are able to choose the technology that has the lowest capex and the lowest OPEX, the profits of your company will be high. And we start with the studies, we verify the technologies, and we start with the heating material balance of the units. And what are the main, for the company, for the business, what are the main deliverables of the heating material balance? It is the energy needed to run the plant, how many kilowatts of water I need to run my plant in 24 hours per day, 7 days per week, and 365 days per year, for instance, and how much raw material is entering and how much product is going out, is produced, and what are the utilities that are needed to do that process. So that is the main deliverables that business are worried about. Uh, and based on the technology that you choose, you will have different kind of equipments. In PSA, I will have in summary 2 vessels with adsolvent, and I will produce the biomethane at the desired grade. If I have a water scrubbing process, I will have vessels, I will have pumps, I will have compressors. I will need hello Liliane, nice to have you here, my friend. We have also a cooling system, so it can get more complex in terms of project, but not necessarily more expensive. So we, as chemical process engineers, we starting doing the heating material balance. After that, we do process flow diagrams, pipe instrumentation diagrams, and all of these is the basis or are the basis for doing is technical specifications for equipments, for control valves, for pressure relief devices, for instrumentation, and etc. So now we are leaving the conceptual or the paper side of the project and going to the physical side of the project, because with the specifications we are able to do quotations in the markets in order to evaluate how much costs to install the plant. I need, if I need a pump for with 10 HP, the price will be different if I need a pump with 100 HP. So you will talk to KSB, to Sundyne, or to other suppliers, ask for a quotation to know how much is the cost of that equipment. But the cost of equipment or the cost of the project is not only the cost of the equipment. Once we buy the equipment, we need to install that in the field. So we are going closer and closer to physical aspects of the project to truly produce the product. So is the part when we are installing the equipment in the field is where we have the plant erection or plant installation. Usually in the plant installation, the chemical engineer or the chemical process engineer don't have too much involvement because all the documentation was already built in the early stages of the project, conceptual, basic, and detailed engineering. However, the main basis to one of the main documents to do the plant erection is the pipe instrumentation diagram. That is the source of information for isometrics, for layouts, for roads of layouts, isometrics, is the main ones that the pipe engineer uses, and the layout of equipment. We have layouts of underground pipings, above ground pipings, and so eventually during the erection of the plant, there may be some changes. For some reason, it was not possible to do the original road of the pipeline designed in the isometrics when the people from the plant installation needs to do another road. And it can be sometimes it's not so easy to change a route of a pipeline. Let's suppose that we are talking about a fluid, a saturated fluid, and it gets in it's the environment, the weather can impact the formation of condensate. So if I have a gas with condensate, I don't want to have a pockets. What is pockets? We come with the pipe at the height. We go to the bottom, for instance, to install a control valve for maintenance, and we return to the top. If we have condensate can accumulate, and we need we need to install some kind of trap to remove this condensate. And if we install this kind of arrangement in a part of the process that was not supposed to have this kind of arrangement, you can mess your production, you can impact the operations of many equipments because you have trap of condensate where you should not have. And that's where leads the chemical process engineer. The chemical process engineer must be consulted to verify if the modification and the original design is acceptable or not, if there are some kind of process safety concerns. And in medium to big companies, we have something that's called management of changes. So this procedure or this activity informs that we need to review the documentation, we need to do a process safety review, we need to get the approval of technical people that is authorized to that, in order that when it is installed in the field, everyone know that a change was made, but it was approved and it is free of hazard, or the process safety is okay. So this is the main role that a chemical process engineer may do during the plant erection or the plant installation. And the next step is, once your pump installed in the field, we have more interactions with the mechanical engineer, like my dear friend Liliane, he's a mechanical engineer. And I went to the field to start some systems, and these systems has pumps, has compressors, has separated vessels, and you will follow the mechanical engineer in many times to verify if the conditions of the pump is okay for starting. The mechanical engineer will do the alignment, they will verify if the nozzles is correct or not, they will verify if the vibration of the equipment is okay or not. So usually these main tasks is not the chemical process engineer roles, but it's nice to you, especially if you are at this phase in the project, to accompany that, because you can get a lot of good knowledge from it. And once the mechanical engineer says, okay, you can start this pump, it's ready for use, we start the pump for the first time, so we will have the startup of the system. And who will adjust the valves to do the correct pressure drop in the system usually will be the chemical engineer or the startup engineer, because now the mechanical engineer said, okay, this equipment is ready for operations, you can start that and operate that. But although we design the equipment for design conditions, we need to do regulate pressure, we need to regulate flow, we need to verify if the temperature is okay or not. and we need to do some kind of adjustments in the control room or in the field in order to get the design conditions that the equipment was designed. So now is the chemical process engineer role to we do as many adjustments as possible to operations work the plant smoothly, and eventually we leave the field. We go back to our company in the town or in the design department, and but in many cases new systems versus is success can happen problems. New systems, the chance of having problems in new systems are big, very, very big. And eventually, if something doesn't start, if the process doesn't run too well, you will be contacted to verify what's happening. Why I'm not able to start my pump? Is it because of I having cavitation, the liquid is forming vapor in the suction of the pump, or the pressure is not rising, what is happening? So in this case, depending on the equipment of course, you will need to interact with others engineers to understand what's happening and solve the problem to operations. And once the everything's okay, you finish the project and you are free to start new projects, and for not forget, but don't be too demanded for all the project. So this is the overview of the plant design in the point of view of the chemical process engineer. Okay, and let me see what time is it. Hmm, what time is it? Okay, guys, I have 5 minutes. So I have 5 minutes to go. I talking already too much, so I will stop for here from here. Very, very nice to have you here in the Chemical Process Engineering Diary, and I hope to find you soon in the next episode. So this is it. I hope you like it, and bye bye.